Look here at example 4. We're asked to find the equation of the tangent line to the graph of f of x equals x squared divided by the quantity 3x minus 1 at x equals 1. Then we're asked to check our answer using a graphing utility. Okay, so in order to write the equation of the tangent line, the formula is y equals f prime of a times x minus a plus f of a. In this particular example, the x value we're looking at is 1. So this would be f prime of 1 times x minus 1 plus f of 1. So f and 1 we can get right away. Everywhere I see an x, I'm going to substitute in x equals 1. So we get the numerator there, 1 squared over 3 times 1 minus 1, which is a half. Now we just need to get f prime of 1, which means we need to figure out the derivative f prime of x. So f of x is x squared over 3x minus 1. I want to take the derivative of that. And as I mentioned when we went through the previous example, if you can use properties of fractions to avoid the quotient rule, sometimes that's a more efficient route to go. Now, if you have a plus b divided by c, you could certainly rewrite that as a plus c over b plus c. So addition in the numerator, you can split up the fraction. In this case, though, we've got addition in the denominator, and there is no distributive property that works for this. So here we're kind of stuck with the quotient rule. And so we've got our low function here, our high function here, and so we get going. Low d high, so 3x minus 1 times the derivative of x squared minus high d low, x squared times the derivative of 3x minus 1. And we square the bottom, and off we go. So we get the quantity 3x minus 1 times the derivative of x squared, which is 2x, minus x squared times the derivative of 3x minus 1. So that's the derivative of 3x minus the derivative of 1, all divided by 3x minus 1 quantity squared. The derivative of 3x is 3. The derivative of 1 is 0. Whoops. So now we get f prime of x equals 3x minus 1 times 2x minus x squared times 3 over 3x minus 1 quantity squared. Now this is where you can get a little cancel crazy. You might think, well, can I cancel these quantities? I got a 3x minus 1 and a 3x minus 1 here. Can I cancel them? Well, no, because you don't have this 3x minus 1 as a factor on both terms. Remember, when we cancel things out of from numerator and denominator, we have to first factor and then cancel common factors. If you split this up into this term minus this term, then you could cancel in the first term but not the second. So we're just going to leave this as is. And as the general rule, we never multiply out denominators in calculus, but we do simplify the numerators. So let's go ahead and simplify the numerator here. It looks like there is an x, though I could factor out of both. So I'm going to go ahead and do that. That'll leave me with a 3x minus 1 times a 2. And minus x times a 3. So go ahead and do that. So x times, so I've got a 6x minus 2 minus 3x over 3x minus 1 quantity squared. And so it looks like for our grand finale here, put that on the next slide. Oop, that's our f prime of x. Our derivative f prime of x equals x times 3x minus 2 divided by the quantity 3x minus 1 squared. And so the slope of the tangent line we want is the derivative at 1. So in the numerator, I'm left with a 1. And in the denominator, I'm left with a 2 squared, which is a 4. So circling back to my tangent line, the tangent line at x equals 1, y equals f prime of 1 times x minus 1 plus f of 1. F prime of 1 is a quarter times f prime x minus 1. And f of 1 was a half. Now, once again, it's up to you. There's advantages to leaving the tangent line like this, as we'll see in the next chapter. But you can simplify this if you want. So you can simplify this to a quarter x minus a quarter plus a half. So it's a quarter x plus a quarter. And now let's see if we if this looks right. So how do we check this graphically? If this really and truly is the tangent line, when I graph the original function near the x value 1, the graph of the function and the graph of the line should be indistinguishable. So let's fire up Desmos to help us with that. So put in our function here, f of x equals, and we'll hit the division sign there. We've got the x squared over the 3x minus 1. We're going to plot the point 1 comma f of 1. So there it is. Boom. 1 comma a half. And we're going to zoom in near that. And now we're going to put in the line we got. Y equals a quarter x plus a quarter. And lo and behold, the local linearity. As we zoom in here, the closer we get to the point 1.5, you can see that the graph of the function and the graph of the line become indistinguishable. Okay, so that helps us verify our answer graphically. And that'll do it for example 4.